Bismillahirrahmanirrahim. My name is Zishan Ahmed. In our channel Conceptual Physics, I will bring a very important lecture about the X-ray production and give the graphical illustration of X-ray spectra. Okay, student, as you can see, this is the graph of intensity as a function of wavelength. So intensity means that is the number of photons in a unit volume. In quantum mechanics, the number of photons per unit volume is called the probability density function that shows the number of photons in a unit volume. It's also also directly proportional to the amplitude of the wave, and that shows the greater number of photons and that particular volume. So this way of graph shows that we have a number of photons at each point. Okay, at somewhere we have a less photons, and at somewhere we have a greater photon as soon as we are moving. Then we have a sharp peaks over there, k beta and k alpha. I will tell you about these peaks after some later time, but discuss this behavior of the curve by means of number of photons. As soon as we are moving towards this curve is increasing over the number of photons. Then we have some peak over there, then we have a less number of photons. So this is a broad spectrum. So in X-rays we have two types of spectra, that is broad continuous spectra or spectrum, is also called Bremsstrahlung. It means, the German word means breaking radiation, and it is the cause of the slowdown of electrons. High energy electrons are interacting with the Coulomb interaction, that means the slowdown of electrons and decelerating. So we have in this range we have a deceleration produced. At somewhere we have a high deceleration, and somewhere we have a less deceleration because of the nuclear field, and the electrons are penetrating towards the target material. So this happen, we have some range of the wavelength. Okay, number two, we have a number of sharp lines shows characteristic X-rays. So we have a two spectrum over this X-ray production. Number one, broad continuous spectrum, Bremsstrahlung, and number two, characteristic X-rays. Okay, now this means we have some important features and some important points about the X-ray graphical illustration. Number one, we have a 0 up to entire kinetic energy, means 0 up to entire kinetic energy means kinetic energy lost by electrons due to the interaction of the target material. And we have some minimum